Hi, in this video I'd like to explain the concept of capacitors in series and what happens inside them, and finally how to derive the equation for the total capacitance. So here we have a battery and the positive terminal of the battery is connected by a wire to the first capacitor through a plate. So the first conductor that you see in the sketch gets a positive charge. The second plate of the first capacitor will of course get a negative charge because it's a capacitor. At the other end of the stack near the blue wire, that plate will take on a negative charge due to the negative terminal of the battery. If you look at an animation in closed motion, the parallel plate capacitors are 3 in number and they are connected to each other by a wire. The first capacitor of course has got a dielectric in between, but you can see the interconnecting wire between those 3 sandwiches, and that's extremely important to note that wire, and the wire plays a role of keeping the same potential between the second plate of the first capacitor and the first plate of the second capacitor. I hope that was not a very confusing sentence. If you look at an image in the top view, you can see that the capacitors are named 1, 2 and 3, and what I meant to say is that the interconnecting wire which you see there between those 2 capacitors ensures that the plates which are electrically connected will have the same potential. So the first plate which is exposed to the positive of the battery will have the highest potential, let's say a potential of 12 volts, but the second plate of the capacitor number 1 will have a lower potential, let's say 10 volts. Now the capacitor number 2, the first plate, will also have 10 volts because the plates are connected by a wire. That's what I meant. And the second plate of capacitor number 2 will have an even lower potential, let's say 8 volts. So the potential keeps on dropping as we keep on adding capacitors, but the total potential difference from the beginning of the stack to the end of the stack must be equal to the potential difference of the battery. In this case, it is 12 volts. So what we do here is that the potential of the positive terminal of the battery is taken as V1, let's say plus 12, and the potential of the negative terminal of the battery is kept as 0, so that the delta V between them is V1 minus V0 equal to 12 volts. So this potential difference between the positive and negative of a battery is called the EMF of the battery, and that EMF applies to this stack of capacitors in series. It's as simple as that. The other details in this sketch are that the positive and negative charges are clearly outlined. So the first plate of capacitor number 1, which faces the positive terminal of the battery, gets a positive charge. It's plus Q. The second plate will be minus Q, and since it's electrically connected to capacitor number 2, you can see that the capacitor number 2 will get a positive charge, but the potential will remain same. So you have an alternating plus minus, plus minus, plus minus. At the last plate, which is connected to the negative blue terminal of the battery, will of course have to have a minus sign because it's the negative terminal of the battery which supplies the negative charges. So it all has to match the way the charges are arranged and the potential drops. So let's look at capacitor number 1. We talked about potential drop. So the plate, conductor plate, which is closest to the positive terminal of the battery, gets on the same potential V1. And please note the words potential versus potential difference. Now the second plate will have a lower potential V2 as mentioned there. So V1 minus V2 is the potential drop due to the first capacitor. It's as if we fixed a bulb out there. So as far as the first capacitor is concerned, Q equal to CV, so Q equal to C1 into V1 minus V2, therefore V1 minus V2 equal to Q by C1. And all these potential drops, as I said before, V1 minus V2, V2 minus V3 and so on, had to add up to the delta V, which is the potential difference of the battery itself. Can't be more or less than that. Now coming to the second capacitor, you can see that the second plate of the first capacitor and the first plate of the second capacitor are electrically connected by a wire. So the V2 repeats on capacitor number 2. Because V2 repeats, then the potential difference becomes V2 minus V3, because V3 has to be lower. And therefore V2 minus V3 equal to Q by C2. Now come to capacitor number 3. Now it is electrically connected to the capacitor number 2. I mean only two plates are connected. So the V3 potential repeats on the first plate of capacitor number 3. The second plate of capacitor number 3 has to be V0. Why? That's because it's connected electrically by a wire to the negative terminal of the battery, and therefore they can't be at different potentials. They have to be at the same potential. So V0 has to show up on that plate. Therefore V3 minus V0 is Q by C3. Now you add up all these individual voltage drops, the principle being that the total voltage drop must be same as the EMF of the battery. Therefore, when you do this equation and remembering to put V0 equal to 0 volts, you will get Q by C1 plus Q by C2 plus Q by C3 equal to V1. And then take out Q and you will get V1 by Q equal to 1 by C1 plus 1 by C2 plus 1 by C3. Now that is kind of a 1 by equivalent capacitance, which is C total. And therefore you will arrive at 1 by C total equal to 1 by C1 plus 1 by C2 plus 1 by C3. I hope this was easy for you to understand. Please revisit this video and it will be more clear. Thanks and have a great day.